Hi there, Pre-Calc students. It's time for another thrilling lesson. This one 1-2 called Composition of Functions. This is something I think you've done before, but sometimes it's a bit tricky, so we'll take a look at it. Now, first of all, we'll take a look at something called function operations. And operations are not like this kind of operations, but with mathematics, you might recall that with operations we mean things like adding, subtracting, multiplying, and dividing. So let's take a look and see how this might work out. Here are my two functions I'm going to look at, f of x and g of x. And this notation here that we're going to look at, the first one, this f plus g of x right here, as you might expect, all we're really going to do is add these functions together. And so I look for like terms. On my two functions here, I don't really have like terms except for my two numbers or my two constants. So those are the ones I can put together. So when I add these two functions up, my final answer will be x squared plus x. And then I can combine the two numbers here, so negative 6 plus 1 is negative 5. So there's my f plus g of x. That's how I would read that. Now, next one here, let's try the f minus g of x. As you can expect, I'm just going to subtract these. Now, this is slightly tricky because when I subtract a whole function, I do have to probably put parentheses around it. So I'm going to write it like this: x squared minus x plus 1. And notice I do put parentheses around my g of x function, because as you might recall, what happens when I put parentheses and then I have a subtraction sign subtracting parentheses, well, it changes the sign of each item in the parentheses. In a sense, it's like we're multiplying by negative 1 using that distributive property. So it changes to minus x minus 1. Therefore, my final answer is x squared minus x minus 7. Notice that would be a little bit different than if I did the g minus f of x, if I reverse that. So the order is fairly important there. Now, the next one we're going to take a look at is multiplication. That's this one here. As you might expect, I'm going to use kind of a FOIL method here. So I have x squared minus 6 times x plus 1. And so I'm just going to use the FOIL method, or the double distributive property is what I like to think of that as sometimes. So I know with freshmen I like to kind of show what I'm going to be multiplying by. So here's my first two multiplications. X squared times x is x to the third, and x squared times 1 is just x squared. That's my first loop-de-loops, I call them. And then going on to my next ones here, I do it with negative 6. So negative 6 times x is negative 6x, and negative 6 times 1 is negative 6, like that. So therefore my final answer here ends up to be x to the third plus x squared minus 6x minus 6. Nothing I can really do there. And last but not least then is the division part there. This one, not too much you can do. All I have to do is write it division-wise, x squared minus 6 over x plus 1. That's the best I can do there. Now we do want to be a little bit careful here. You remember that our denominator can never equal 0, and so I'm going to say then in this case that x cannot equal negative 1, because if I put negative 1 in there, it would indeed be 0. So that's just some basic function operations with not just numbers but with the bigger functions. I get to the actual composition part here, and I found a little chart here that might help you understand this a little bit better. Here are my two functions, f of x and g of x. And what I'm really doing here with this composition is this thing right here called the f of g of x. In a sense, I'm doing two functions at the same time. And the key thing here, as you can see with this, these people in the cars, when I have this f of g of x, I start with the g function. So the g function is 2x, and we're just saying that the domain of that is 1, 2, 3, and 4. So then I put 1, 2, 3, and 4 in place of x. And notice I'm just doubling each of those. That's why I get the 2, 4, 6, and 8. Then, my final step in the composition process, I take the 2, 4, 6, and 8, and I put those in place of x in the other function here. So obviously I'm just adding 1 to each one of those, so my final answer then is 3, 5, 7, and 9. One thing that I find is kind of helpful is this f of g of x here. It does really mean the same thing as this. And I kind of like writing it like this because it does give a good indication that you have to do the g of x first, evaluate that first, and then go to the f function. Well, let's take a look at this, and we're going to do some examples here on the next slide. So here are my two functions, my f of x and g of x. So first of all, what would this f of g of 3 look like? Well, I like to rewrite this. I'm going to write it as the f of g of 3 like that. So that tells me that I work from the inside out. I first of all do the g of 3, which you can probably do in your head. Put 3 in place of this x. So 2 times 3 is 6, plus 1 is 7. So then that really means that I now have the f of 7. And then I simply put 7 in place of x, but notice this time I have to do it in the f function here. And so I put 7 in place of x. 7 squared is 49. 49 minus 1 is 48. So there is the f of g of 3. Now what happens when I don't have a specific number? What happens when I go to my second example here if I have just the f of g of x? Well, I still would write it as this. Now, well, first of all, I think I'm just going to write it like that, the f of g of x like that. And I'm going to substitute that g of x right away. So I'm going to put that 2x plus 1 right in there in place of g of x. And now, just like I did on the previous example, I am going to substitute. So I have to put this 2x plus 1 in place of x in the f function here. So what this is really going to look like then is 2x plus 1 squared minus 1. Why do I have to square it? Well, because in the f function, this x is also squared. So I'm going to quickly do this. This is my FOIL method here, but my answer there is going to be 4x squared plus 4x plus 1. I kind of skipped the FOIL method. You may want to do that to understand how I came up with that answer. That's just the squaring part. Then I still have to subtract that minus 1, which is still there. So my final answer here will be 4x squared plus 4x. All right? And finally, my last one then, the g of f of x. This composition is not commutative. In other words, when I switch the order, I will get a different answer. So let's see what that would look like. This time I'm going to write it like this, the g of f of x. Here we go. And so now I'm going to substitute once again that f of x, which is x squared minus 1, just like that. And then I'm going to put that x squared minus 1 in the g function. So in this case, I have 2. That's my g function up there. Here we go with my x squared minus 1. That has to be in parentheses, plus 1. Do a little distributive property here, and I get 2x squared minus 2. The plus 1 is still there. My final answer then ends up to be 2x squared minus 1. So there's a couple of good examples of this composition and what that looks like. What we want to talk about is something called iterations. And iterations are, actually compositions are an example of that, because iterations is anything that is repeated. And with pure iterations then, our output, in other words, the answer we get becomes the new input. And we can do as many of these iterations as we want. So here's our example. find the first 3 iterations of that particular functions that has the initial value. By the way, that x0 there, that's just called a subscripted variable. Don't be too confused by that. So anyway, my first iteration then will look like this. I start with x0 equaling 4. And so my first answer then, which I'll call x sub 1, simply will involve putting 4 in place of that x. So this is going to be 3 times 4 minus 2. So that's 12 minus 2, which is 10. My next iteration, I'm going to take this 10 now and put 10 in place of this x. That's where the iteration comes from. And so now I'm going to have 3 times 10 minus 2. That's 30 minus 2, which is 28. And my last answer then will be x sub 3, and you probably have figured this out by now. Now I'm going to put 28 in place of x. So I'm going to have 3 times 28 minus 2, like that. And 3 times 28 is going to be 84, I think. 84 minus 2 is 82. All right, so that's the basic structure for this lesson 1-2. Thanks for listening, and we'll see you guys tomorrow.